السلام عليكم. معكم فالح حشلوي من مركز الاتصالات المستقبلية والمستشعرات اللاسلكية. نشكر كل الحضور على الحضور في هذه المحاضرة، ونشكر أكاديمية المدينة على إتاحة الفرصة لنا في تقديم هذه المعلومات عن تقنية إنترنت الأشياء. طبعا بتكلم باللغة الإنجليزية لأنه بعض المصطلحات صعب إني أشرحها بالعربي. فاليوم أنا بتكلم عن تقنية إنترنت الأشياء في الطاقة الكهربائية. Here is my content. I want to talk give a brief introduction, and then I want to talk about the importance of Internet of Things in smart grid. Then what's the components of Internet of Things. Then I will talk about power grid flow process. Then what's the smart grid architecture? What's the advantages of using smart grid? And what's the challenge we face it if we apply smart grid? And some of the problem and solution. And I will show you some of the case study that has been done. What do you mean by Internet of Things? Internet of Things, if we link physical place or things to the internet. So if we make things able to send or receive data, we call this thing is smart. Why? What's the importance of applying IoT in smart grid? Because the electricity is play an important roles in everyday activities. So any short period or any blackout in the power will need to negative impact in many sectors, such as banking or health sector or any another sectors. So if we apply smart grid in this and power grid, we will let the system redirect the power to the sector where it's most need. According to the Department of Energy in the US, the blackout in the United States cost them 150 billion each year. Also, the economical impact of IoT, based on the Cisco analysis, it will be 14.4 trillion in next decade. What's the main components of IoT? We have 4 components. We have a sensor, and we have IoT gateway. Then we have cloud. Then we have smart devices. Sensor, we have many different type of sensors, such as motion sensor or temperature or pressure sensor. And you may ask what's the gateway. It's so I want to talk a little bit what's the difference between modem and router and gateway. So the modem is make connection between the network provider and the internet, and the router that devices create home network. And if we combine those together, we will get gateway. The power grid flow process. Here is the process of the power grid. It comes from the source. It could be any kind of power source, like renewable energy or solar cell or any kind of power source. Then it goes through the transmission. Then from the transmission to the distribution. Then from the distribution to the customer, such as a building or houses or any type of customers. If we want to apply Internet of Things in smart grid, we have 4 layers. The first one is called devices layers, such as a sensor or camera or smart devices. The second one is called gateway. Then we have a network layer, such as internet or public mobile network, and we have application layers. What's the advantages of using IoT in smart grid? There are many advantages. One of them, the power is renewable power, and also it will be reliable. It will reduce failure, and also you can track your usage, and it's compatible with smart home and smart grid. Over applying this technology to the smart grid, it has some challenge. I classify this challenge to 3 challenges. One of them is called a technical challenge, and the other one is data challenge, and the third one is communication challenge. In terms of technical challenge, it's heterogeneous. What do you mean by that? Not all the devices has the same specification and the same features, and also the power source for it has many different power sources. Some devices they need high power source, and other devices need low power source. Also, near real-time data delivery is required for all the devices. When we apply, when we want this device to work in harsh conditions, such as extreme cold or extreme hot, we don't know about the reliability and compatibility for these devices to work in this condition or not. Also, there is no unified standard for IoT devices in smart grid. In terms of data challenge, we have many challenges such as data quality, data uncertainty, which means some data has noise, some data unclear, and also the security, privacy, authentication, and also the latency. For the communication challenge, also there are some challenge because the smart grid must support the necessary communication protocol. That the information exchange between those devices, it's really very critical, and we don't know how many antenna do we need to work for this technology, and if we need to make more synchronization between sleeping optical mode and power saving mode for some devices, they need a careful design. So I want to take one of these challenge and go in depth of how can we solve this challenge, and I want to show you some suggested solution. So if I want to take one of these challenges, the communication challenge. If we want to talk about the communication, we have two types of communication. We have wireline and wireless. I want to take, for example, wirelines. What do you mean by wirelines? This could be power line communication. It's called PLC or optical fiber. The wireless, it's like a popular communication such as Wi-Fi and WiMAX and cellular network. Some of these communication used for short range, such as Wi-Fi and Bluetooth, and some of them used for long range. And you may ask what's these letters BAN and HAN and NAN. BAN, it's mean a building area network. HAN, it's mean home area network. And NAN, it's neighborhood area network. Most of company, they use cellular data. They have to rent infrastructure from the telecom company, which costs them a lot, and they have to subscribe in the internet package to get the data from these devices. Based on the statistic from Cisco, they say the internet estimate to be 20,150 petabyte, which equal 241 billion gigabyte per year. And that cost 0.51 per gigabyte, which cost them a lot. One of the joint project was with CAST, I think CAST with National Water Company. They have the same problem, and one of the solution we proposed using LoRa technology. So this is one of the solution using LoRa range, long range radio. It's called LoRa. You can see here in the right, in the left graph, the range of LoRa is more wider than the cellular or Bluetooth data. It's because it's used spread spectrum. This is a sinusoidal waveform, support data transmission for over distance. What's the architecture for LoRaWAN? They have four main components. The first one, it's called a node. What do we mean by node? We mean it could be sensor, it could be smart meter, or another type of node. Then we have a gateway, then network, then application server. One of the case study, they used this guy's from Buter from France. He made experiment in 2021. He placed the antenna in different place, and he want to measure the distance, how many kilometers he can get the signal from the antenna. And he placed the first one in 0.62 kilometer, and the other one is for 9 kilometers. And he came up with the big advantages of LoRa technology is using ISM operation band. This band is called an industrial scientific medical band. This work in 886 megahertz, 915 and 923 megahertz, which give a feature for LoRa to be lower transmission loss and much penetration through obstacles such as building or walls or trees. Also, the other feature for this frequency, it will be the interference with Babylor frequency for 2.4 and 5 gigahertz, which used for Wi-Fi and Bluetooth, will be avoided. Here's the here result. The signal strength from different antenna, and the other experiment has been done by Muhammad Abbasi from Azad University and Muhammad Hussein from Ferdowsi University. Those guys, they used smart monitoring. They placed LoRa, and they have 3 different configurations. They name it SN1, SN2, SN3, and they run this one, this experiment for 1 day, and the radius was 99 meters. And they came up with the best practice for this configuration SN2, because it's the data extract rate, it's bigger than 0.9. And when they increase the number of nodes, they notice the data extract rate is falling down, but they didn't mention how many nodes they need or what the ideal number of nodes for each gateway. Also, they made they use the second experiment. They use LoRa gateway for smart lighting and smart metering, and also they have 3 different configuration, and they name it SN1, 2, SN2, SN3, and they run this one for 1 month, and the radius was 15 kilometers. Number of node was 500. And they came up with the signal LoRaWAN gateway is able to handle up 20,000 bulbs in area of radius 15 kilometers. And here is the result of their experiment, and the range of antenna and LoRa efficiency. They increase the distance from base station from 200 to 1,000. They try to see if there is a difference, if they increase the distance or not, and they get the best result they get for SN1. SN1, it's greater than 0.8, and for the other one, for the second experiment, the direction antenna on the LoRa network efficiency, the number of nodes 200 to 1,000, and they run it for 24 hours, and they notice the data rate, extract data rate, it's fallen down because they increase the number of nodes. And they came up with the direction antenna, in the majority of the case, can increase the signal again, and also it will be decline the interference with another frequency. The third experiment, they try to examine the interference with another signal, and they have 3 different configurations. They name it SN1, SN2, SN3. They run this experiment for 24 hours. The radius was 15 kilometers. The number of nodes from 100 to 8,000. As you can see here on the left graph, 1 interference, and with 1 and 2 and 4 interference. And the bottom of the graph is the number of nodes, and this is without directional antenna. And after they put directional antenna, they have 1 interference without directional antenna, and 1 with directional antenna. And the second one, they increased the number of interference, 2, 3, and 4. And they came up with the direction antenna increased the signal strength and avoided the interference. To sum up, there are only few studies about experiment about LoRaWAN capability for smart application, but smart monitoring and smart lighting and smart metering are viable alternative based on LoRa technology. Compared to the traditional solution, they are more cost effective, provide greater penetration, fewer gateway, and more energy efficient. This is the end of my presentation. Thank you for your listening. If you have any question, you are more than welcome.